So let's talk about section 6.1, higher degree polynomial functions. Now, with the higher degree polynomial functions, let's learn how to identify them, also learn about some of the more commonly used ones, and then we're also going to talk about the mins and maxes, which we've done before. So our first thing that we got to talk about is what did we actually have learned up to this point? So previously we learned about linear functions. And with our linear functions that we learned, they took of that form y equals ax plus b. Now, one of the things that we know about linear functions is they look, I know that's not a very straight line, but they look like basically a straight line, okay? So you've seen them before, and this is literally what we spent most of the very first part of the course looking at, were these straight lines. Now, remind yourself that these straight lines could be tilted to the left, they could be tilted to the right. We could even have them in a horizontal format. Okay, those were like the three different shapes that were what we call a linear function. Now, there was one other linear line that we talked about, which was the vertical ones, but remember, they did not classify as functions. But what you want to make note of is kind of this base shape here. Okay, and notice that this has got an x in it with a higher power of 1. So like this is kind of our base idea for a linear function. Now, quadratic functions basically have that ax squared plus bx plus c. Now, remember, these were the ones that had that kind of parabola shape to them, okay? Again, the shape is actually called a parabola, but most people say like a U-type shape, okay? And again, these were our quadratic functions. Again, notice on this one, again, what you really want to notice is that nice power of 2 on there. So both linear and quadratics are going to kind of come back, and we'll talk about that. Previous knowledge, again, this is something you are not allowed to forget, is an x-intercept. And remind yourself that basically an x-intercept is where you basically plug in y equals 0 and then solve it for the x value. So this has got to be some type of number. It can be anything, positive, negative, it can even be 0. But again, you set y equal to 0. We also talked about maximums and minimums. We really focused that on the quadratics. And when we were in the world of quadratics, we said that they were the vertex, but they did go by the name max or min. Okay, now what you want to make note with these when we talk about maximums and minimums is that basically if we go from increasing to decreasing, we have a max, and we have a min when we go from decreasing to increasing. Okay, and you can actually have both at the exact same time. So keep everything that we just did in mind, and let's talk about polynomials. Now, polynomials are basically any function that has a positive integer power on the variables and coefficients that are real numbers. And that creates a polynomial function. Now, interesting enough, these two things here that we learned, so the quadratic and the linears, they actually meet the idea of what a polynomial function is, okay? Again, the word is positive integer powers on the variables and then coefficients that are real numbers. And those examples of what we were looking at for linear actually and quadratic were both that, okay? Now, what you see here is the standard form of way it's written, because again, nowhere in here did I say what power it had to go up to. So let's take a look at some examples of what we've already seen previously. So we've seen constant functions, which are basically say y equals -6. And we've seen linear functions, which have been like 2/3 x plus 7. And we've even seen like quadratic functions, which are like 3x squared minus 5x plus the square root of 11. Okay. But what you want to make note of is basically in the constant function, there is no x value. So we say the degree is 0. In a linear function, we say that this is the only x value term, and the highest power it's raised to is 1. So therefore the degree is 1. And the same thing with the quadratics, okay? Now, with polynomials, we are going to come out with some new terms that may be new for you guys. So when I say the word in behavior is talking about what happens to the graph as I'm going to the left or the right, okay? So I know it says as x approaches positive or negative infinity, but think of it as basically as x goes far left or right. If you don't see it with the infinities, that's basically what we're talking about there. The degree is going to be another new term. And again, I've already kind of used it already, and it's the highest power x is raised to when the polynomial is in that standard form. We also have the leading term, which again is going to actually go back to the degree. The term in the polynomial that actually has the highest power on it in that standard form, that whole term. And this would, when I say the word term, again, this is that key thing, term. This is going to be the sign plus the number plus the variable plus that power. Okay, the whole thing makes it the term. We also have the leading coefficient, which the leading coefficient is going to be the coefficient from that leading term. So it's going to take what it comes from this up here. So, and for this one, it's just basically the sign plus the number. We don't actually care about the variable or the power on the variable because the coefficient is the number in front of those variables that are being multiplied to it. Okay, then we have our local max or mins, which again, we have seen these before. This is not new terminology. We've talked about them previously. And this would be also called turning points. And again, they're where we go from increasing to decreasing or decreasing to increasing. And the last thing is an absolute max or min. And again, an absolute max or min, you'll notice when I start talking about the term here, the absolute highest point or lowest point on the graph. It has nothing to do with increasing or decreasing. It is literally what is the highest point on the graph. Now, normally when we talk about these, we are talking about in terms of y values. So with those polynomials that we were talking about, we looked at constant, linear, and quadratic, but there are two others that get special names right off the bat, which are cubic. Okay, and that cubic function is a function with variable x that's of the form ax cubed plus bx squared plus cx plus d. And again, what you'll notice, what you kind of want to zero in on there, is that notice the highest power on which x is raised to is 3. This is how I know that it is actually cubic. Okay. Now, again, in most graphs, when you're looking at them, a polynomial function, whatever degree it might be, will have at most that many x-intercepts. So since this is degree 3 that we're talking about here, one of the things, again, so I see that it's degree 3, that means that there will be at most, and again, keyword there, at most 3 x-intercept. Now, because that degree is 3 and that's an odd number, that does mean that we will always have at least 1 x-intercept, but that's not always the case. There is a way for us to have no x-intercept when we saw that with our quadratics. Okay. Now, the end behavior on these ones look a little bit like this, where the graph itself can kind of look like this, kind of like a wave shape. Okay. It could be not even that big of a wave. It can be just like a very thin wave like this. So it's kind of got that one side up and one side down type thing, but it might actually have some extra curves in the middle, as you can see here. Quatric is our other one that we give a special name to. And again, quatric, I know it's quatric because it's degree 4. Now, again, because it is degree 4, we talked about it just a moment ago. Degree 4 leads to having at most 4 x-intercepts. Now, you'll notice on this one, I am not going to say that there's at least 1 because this is actually the case where there could be none. But what you want to make note of is kind of the end behavior of these. So what I have graphed here, this is just your basic shape. If it was just everything else, if all of this had just disappeared and you were just left with x to the 4th. Okay, but be aware that this does actually have kind of some other things to it. So it can look a little bit more like a big W or even an M if I flip it upside down, because remember we learned about transformations. It could be something that looks like this. So like it's a little bit more kind of one side is longer than the other. So these are all different types of polynomials. So you've got constant, linear, quadratic, cubic, and quatric. Those are all polynomial functions, and they actually have special names. So let's actually graph this using the appropriate viewing window. Now, what I kind of want to note before I even put it in the calculator is I want to note what degree x is raised to. That's the highest. Okay, so this is degree 3. And what that tells me is that the very basic shape of x to the third is this shape right here. Now, if we don't see that kind of shape going on the calculator, that means I'm probably going to need to adjust my viewing window. Okay, so let's go in and let's actually graph y equals. Okay, so let me pull up my calculator. Okay, and so I'm going to type in my x to the third minus 27x. And then I'm just going to hit zoom 6 because, again, I always like to start fresh with a standard viewing window. Now, as you can see there, oh no, I don't see that kind of like one edge going up and one edge going down. I can see like the graph looks like it's doing something, but I can't say like really if it actually comes up and turns around. So what I'm going to do is I'm going to hit the window button, and I'm maybe going to go to like, we don't want to mess with the x's actually, leave those be. Because I want to go kind of up here. This is a y value, so I want to actually mess with the y's. So let's make the y's like negative 20 to 20. Okay, now this is a bit of a guessing game because they gave me no window to go with, but if I need to, if they gave me a window to adjust, I would go in and hit window and make adjustments as they kind of gave me what to adjust with, okay? Whatever that may be. So looks like my guessing is like really off here. So what I'm going to do is I'm actually going to kind of show you guys what they have. So the best viewing window that you can see there is actually from -8 to 8 and then -60 to 60. So let's go and adjust ours that way. So like -8 to 8 and then skip this. Now, if you want to click it and change it to something else, you totally can, but I'm not going to mess with it. And then what was that? -60 to 60. I forgot the negative on my X-Men. There we go. And we can see that now my graph looks a lot like that. And I can actually see that whole shape. I can see where it's kind of, again, remind yourself, I went to that x to the third and I was looking for how high up, how high down does it go. While I'm looking at the graph there, so again, you can look at it on your calculator. Kind of a couple of things that I begin to notice. The first thing I begin to notice is 1, 2, 3 x-intercepts. And I also see that I have a high point here and a low point here. Now, these are basically what we would call a local, okay, max or min. They wouldn't be an absolute because, again, this is not the highest point on the graph because if I keep going up, 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 I have a high point like way, 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 way up here. And again, this isn't the lowest point because, again, if I follow this, this keeps going down, 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 down. So there is no absolute max or min, but there is kind of what we call a local max or min. Okay. Now, why don't we find what they are? Now, I know that you guys can see them here. Okay. So let's find the local max or min. Again, I know you can visually see them on the graph here, but how do we use the calculator? Okay, let's remind ourselves how we did this in the calculator. First, adjust the window to make sure you can see everything. Okay, and then we're going to hit second trace. Again, we've done this before. This is not new, but again, sometimes we need that friendly reminder. So second trace, and then let's go for the minimum first, number 3. Now you should see this blinky cursor show up. So I'm going to scroll that blinky cursor where I think the low point is. And then I'm just going to go to the left of it just slightly and hit enter. And then I'm going to go to the right of it just slightly and hit enter. At this point here, again, the next question is guess. Again, I'm going to have to go to where I feel like is the lowest point there. Okay, be sure that these two arrows are pointed in at each other. If they're not, you're doing something wrong and therefore you won't get a correct answer. Okay, do be aware that most of these you're going to round to like 2 or 3 decimal places, and if yours comes out to be exactly 3, that's great, because that means you probably had like a really good window and you were really good at your left and right bound. But it does happen to where sometimes they look like they're slightly off, but again, it is 3 and -54 there. Again, I can repeat that process. Second trace, number 4 for my maximum. Again, this time I have to move my blinking cursor all the way over to the left of the high point here, hit enter. Again, how do I know I'm going left? It's telling me with these questions that it's asking me. And then it's going to ask the question after I hit enter to be to the right of it. And then after I hit enter, the last question is always the guess. And look at that, it ended up being perfect this time. So my left and right bounds were right spot on to give me -3 and 54. Okay, so again, these are things that you can, if you have the graph here in front of you, you should be able to kind of see it. However, there are sometimes like when you're looking at this graph that you're like, oh, wait, I can't see everything. Okay, so this is if you're looking at the whole graph here, and we call these local max and mins. Now, what if I ask you for what's the absolute max and min? Now, with this being said, there's a couple of things I want to clarify and point out some keywords. The first thing is it asks for the absolute max, okay? And it also asked it for this interval here, okay? So remind yourself that when they go this route here, this is basically all the x's must be between 0 and 3. So we can take a look at the graph. Now I'm going to kind of just look at the graph here, and I'm going to show you, this is the graph we were looking at. So if my x's are between 0 and 3, that means that basically none of this part of the graph exists. Okay, so the graph starts like right here, but it stops at 3, which is right here. So this part of the graph isn't going to exist. Now, there's really not a great way to show it in your calculator when it only shows like from this interval of 0 to 3. But if you can just kind of imagine it doesn't exist, okay, whether that's covering it up with your hand or anything like that, and then just look between 0 and 3, what is the highest point there? Well, our highest point there would be right there, which would be our 0, 0. And that's where that would be considered an absolute maximum. Again, I know we're kind of used to seeing that this hill up here is a maximum, but that's not the case when we're looking at this. Okay. Okay, so the table here is going to show millions of elderly workforce for the years 1970 and projected to 2050. Now the data can be modeled by the following cubic function. They've already given us the model, so that's really nice. Okay, and X is the number of years after 1960 and Y is in millions. Okay, let's see if whether or not the model is actually a good fit. That's going to be our first thing. Now, remind yourself that if we're doing this and we're having to use our calculators to see if a model is a good fit, okay, again, somewhere in the problem it talked about X is the number of years after something. And that's very important to make note of, because instead of me typing in my list 1, you better not type in 1970, you better type in 10, okay, 20, 30, 40, 50, and then again, here we'll have 60, 70, 80, and 90. Okay, now remind yourself how you do this. So let me go and pull my calculator back on screen. Okay, and remind yourself that when we have these data to put stuff in the list, so I'm going to go back to the home screen. I always like to start fresh here. I'm going to hit Stat, Edit. Okay, and then I'm going to type in my numbers. So again, remind yourself again, we're talking about the number of years since 1960. So we start off with 10, 20, 30, 40, 50, 60, 70, 80. And I believe it was 90 for the last one there, correct? Yes, it was. Okay. So, and then type in your numbers. Again, always go back and double check all those numbers are correct. It's very easy to make a mistake. If your numbers are off even just slightly, you'll end up with the wrong answers and you don't want that. So I'm going to pull this off screen. Pause it if you need to pause, so that way you can continue on working with me to make sure that you're also on the right track. Okay, so hopefully you've had time, you've paused and inputted all this. Now, don't forget, you also want to input the model. They gave you the model, so let's look at that. Now, remember, once we have our list in there, so we have stat, edit, we've got our list in there. We went into y equals. Now, look up here, notice how plot 1, plot 2, or plot 3, neither one of them is turned on. So I do want to kind of go to second y equals and go to my stat plot and turn it on. Again, that way it'll put all the dots in there. And so when you do all that and go back to y equals, now notice how like there's a black box around it, and that lets me know that I've got it in there. Okay, now remember to see it, instead of you having to figure out what to adjust the window to, Zoom 9 is your best friend here. Okay, and when you do that, you can kind of look at that and take a second and take a peek at that and decide whether or not that is considered basically what we call a good fit model. Okay, so it looks like the model's a pretty okay fit as we were looking there. One of the things that does worry me about that is that even though it does look like it's a pretty good fit, there's a bit of the area that's not absolutely perfect. So like over here, it doesn't hit very well. It looks like the numbers kind of do this and then kind of do like a little dip down and then back up. Whereas it looks like it's kind of on an upward trend here, and the model looks like it's a downward trend. So it looks like it's a somewhat okay fit, but I'm not 100% sure just based upon I don't have enough data going outwards, which is why when we talk about our models, that they're only good for so many years. You can't go too far out after all your data ends, because otherwise you don't actually have data to use, so you can only like predict very close to like what's going to happen afterward. Okay, so we're going to use that model and we're going to predict what is going to happen for the number of models in 2025. Now remember, the first thing is that we have to, again, this was so important, I can't stress this part enough, is that somewhere the problem, again, anytime that had talking about years, there's normally somewhere where it says X is the number of years after something. Now that does mean that we need to make kind of an adjustment there. So remember, X equals 0 was the year 1960. So if I'm in the year 2025, how many years have actually passed? Okay. And again, you can kind of use your calculator to help you out with this. It's actually not as bad as you think. So what I would do is just very quickly go into my calculator and go 2025, because that's the year we want to know, and just subtract out your 0 year, because this is how we figure out our age, how many years have passed since we've been born. The same thing's going to happen. So I got X equals 65 there. Now, since X equals 65, we're just going to take 65 and plug it back into our model, and we're going to get our answer. Okay, so in the year X equals 65, if I plug 65 in for all the different X's here, I'm going to get 8.68, which basically means that the model predicts that in the year 2025, there will be 8.68 million people. Okay. So let's take that again, and let's use the technology and the model that we had and find the year in the period between 1960 and 2060 for which the number of elderly workers is predicted or expected to reach its maximum. Okay, so again, this is kind of where you want to remind yourself that we're kind of in between these years here, and we're looking for a maximum. Now, this is not, okay, again, kind of look for some keywords here, and I know this is where a lot of people, it says use, oh, sorry, I did not mean to show the answer already. it says to use, and I know this is where a lot of people, but use the model. It doesn't say use the data given, it says use the model. Okay, now this is where as you're doing this, so let me go ahead and go back into y equals. We've got the model already plugged in, but right now currently if I hit graph, it's going to show the points and the model. I do find that when you run the second trace and then looking for maximum, it is a little bit easier if you don't have the dots there. So you can always turn them off. They shouldn't affect it too much, but just in case, I would kind of turn it off. Okay, so hit your enter for your left bound, go past it, hit enter for your right bound, and then where you think that guess actually is. Okay, again, if the dots are distracting, what you can do is just go into window or y equals, head up to that plot one, hit enter to turn it off, and now it's off. And then you're good to go. And you'll just see that line in the areas that you want to see it in. Okay. Okay. And we got the same answer. Again, my answer was very, very close to it. So remind yourself that when you're doing these, and I can't stress that enough, like it's your number and my number is actually going to be pretty close. What's going to be different is basically maybe the last, as you can see here, like I got 443 when I ran it this time, and here I got 436. Okay. So this is why, like a lot of times when you're doing these problems, they are going to ask you to round 2 or 3 decimal places, just so it's pretty accurate in that sense there. Because once you start getting into the nitty gritty, like down into like the 4 or 5 decimals out, this is a calculator. There's going to be room for error, and it's kind of doing a program so there's kind of like a small room for error there, which is why we kind of say it's approximately equal to this or that. Okay. So as you guys can see, we basically reached that maximum of 10.3 million in the year 2044. Now, if you're a little unsure where I got the 2044, guys, do remember that we said 83.8 is our X. And we do have to figure out what year does that correlate to. Now, you're going to have to take your 0 year, which is 1960 in this case, and basically add it to that. So you basically have 1960 plus this 83.8, which means you're basically already 2043.8, you're 0.8 into the next year, which actually makes it 2044. If there's any decimal here, basically take that number and round it up to 84 before you add it to 1960. Okay, and that's why I know it's 2044. Okay, so we do know that a local minimum also is going to occur at 20.5 and 2.78. But what does the function do on the interval of 20.5 to 83.8? Okay, so again, I've already done the stuff for you to find that minimum, but if you want to play with your calculator and find that, that's perfectly fine there, okay? But remind yourself that right here, when I look at this, this is actually, again, X values. It's between, okay? So take a peek at that graph again. And again, I've got the minimum is right down here. And that's that lovely 20.5 to 2.73 is that order pair. So I want to know what happens between this X value here and this X value here. So again, when I'm asking what's happening, kind of think of like what's going on. This looks like we are kind of going an uphill battle there, which means we are increasing. Okay. Okay, so now that we've learned a little bit about that, let's kind of go a little bit more in detail on polynomials. And before we can jump too far into polynomials, we do need to talk about this thing we call leading term test. Now, a leading term test basically tells you the in behavior, okay? So when I ask you to do the leading term test or something makes a note to do the in behavior, like what happens with the in behavior of a graph, that's what the leading term test is going to tell you. Okay. Now with that in behavior, let's point out a couple of things. So your degree can either be even or odd. Okay. And that leading coefficient can either be positive or negative. And that's really the only choices I have there, is that it can either be positive or negative, or we have even or odd. Okay. Now, if it happens to be even and positive, both sides are going to go up. But again, you'll notice I have this like open area here because again, I'm not 100% sure what's going to happen in the middle here. Okay. If it's odd, one's up and one's down. Okay. And think about it. Evens are things that goes in pairs. So two, both going the same, odd, one way and one way. So one up, one down. Now, if that leading coefficient is negative, both of those pairs are going to go down here. And then if it's odd, it's going to go this way. Again, still one up, one down. Now, we've kind of done this with the evens already with our whole quadratics where you had the happy graph or the sad graph. So maybe keep that in mind with your even. Are we happy or are we sad? And that will tell you the in behavior. It's a little bit harder with the odd, but I do have a trick. And so your trick here is that if it's an odd, we always know it's going to be one up or one down. Okay, like it's always that way. But whatever this is, so we end, again, think about it. We read our book from left to right. We read our graphs from left to right. So we end on our left side to our right side, going to our right side where we're ending. We end on the note of what that sign was. So if it's positive, we end up. If it's negative, we end down. And because it's odd, you've always got one side up and one side down. Now, also with polynomial functions, there's a lot of things that I can learn about them. A couple of things that I want to make note of is I do want to make note of that in behavior. So again, this is where that in behavior comes in that we were talking about, and that's where that whole both sides up or both sides down. But what I also want to make note of is how many turning points could there be? How many turning points can help us identify what the degree is, but we also want to add in the number of x-intercepts. That between the two of these, I can kind of tell you what the degree of any type of graph will be. Okay. And then with the in behavior, that is also another indicator of pretty much its degree. Okay. That's going to narrow it down to being an even or an odd degree. Okay. So we're going to complete the graph of the polynomial shown here, and we're going to determine a couple of things. The first thing is we want to determine the number of x-intercepts. Now remember, x-intercepts are the places that it crosses the x-axis. So I can see here and here it crosses 2 times. Okay, now looking at that graph, how many turning points are there? Well, we go from decrease to increase. I only see 1 turning point here. Okay. Now, with that, with just that information, we're going to kind of answer C and D kind of together here. So what I want to know is whether that leading coefficient is positive or negative, and then also is the degree of the polynomial even or odd. Okay, first of all, again, look at the in behavior, and both sides are up and together. Okay, so since they're together, that automatically tells me it's even. Now, is it positive or negative? Guys, I have a happy looking graph, so I'm going to say it's positive. Okay. Now, with all of this information here, I can actually determine what is the lowest degree that this could possibly be. Okay. Now, that does not mean that that is the degree of the graph, but it's the lowest degree it could possibly be. So the first thing I said is that it had to be even. So our lowest even would be 0. Okay. So that's kind of where, again, taking into account that we have the fact that it's even here, we know our number of x-intercepts, and we know our number of turning points. All of this together will actually help me determine its minimum degree. Okay. Now, will the leading coefficient help me determine? Not so much. The coefficient is just kind of also to help with the in behavior part of it, but it does come in handy later. So we do want to make note of it. So our even numbers there. So if we think about evens, you're looking at 0, 2, 4, 6, 8, 10, and so on. Okay, now I'm going to start to rule a lot of these out. Okay, I've already ruled out all the odds, but the first thing I'm going to rule out is it can't be 0. Okay, the fact that it has a turning point, it has to be some number bigger than this. So that leaves me with 2, 4, 6, 8, and so on. Okay. Now the number of x-intercepts also tells me that as I'm looking at it, it has to have this minimum number, so I can see that there's at least 2. So I'm going to keep 2, but it could possibly be 4, 6, 8, 10, and so on. Okay, so what is the minimum degree that I could possibly have? And the smallest number up there in the even pile would be 2. Let's try this again. So again, we're going to kind of go through that and take a peek at all the different things that we're going to do. So the number of x-intercepts, the number of turning points, whether the leading coefficient is positive or negative, determine the polynomial's degree being even or odd, and the minimum possible degree it could possibly be. Now again, if you need to take a second and pause here and try to do this on your own. Okay. So let's start with a number of x-intercepts. And again, guys, this is nice. And just, you're literally looking at the graph and going 1, 2, 3. So I see 3. Okay. Number of turning points. 1, 2, 3. I see 3 turning points. Okay. Whether that leading coefficient is basically positive or negative. Now, again, remind yourself that when we did this one, we also did this with our degree, whether it was even or odd. Okay, so if you look right here and here, we can see that we've got even. And so they're going together. So it's an even degree, but again, sad looking graph because it's kind of both pointing down. I would say that it's negative. Okay. Now, how do I determine that this has got a lovely minimum degree of 4? Now, I'm already going to tell you the answer is 4, but I want you to understand how I'm getting that. Okay. So the first thing I said as I was working my way through these, and again, it may have like gone over your head real quickly there, but we talked about the fact that it was even. So again, 0, 2, 4, 6, 8, 10, ... Okay. Now, the first thing I notice is that the number of x-intercepts is 3 and the number of turning points is 3. So that automatically rules this out and this out. It has to be 4, 6, 8, 10 or bigger. And again, the key word here is I'm asking for what is the minimum degree. So since you've already ruled out 0 and 2, the minimum degree is 4. Okay, let's try this again. And again, as we're doing these, we're kind of using that information that we know. So number of x-intercepts. Again, how many points does it cross there? 1. Number of turning points. Okay, now this one is a little bit harder because again, remind yourself that when we talked about turning points, and this is where, like I say, some people get messed up on this. Turning point means it has to go from decreasing to increasing or vice versa. So if you'll notice here, I go from decrease to decrease. So this one actually has 0 turning points. Okay. Now, the next question is basically whether it's a positive or negative leading coefficient and its degree being even or odd. So I notice here I'm straight up and straight down. So that automatically tells me I'm in the odd because I got 1 up and 1 down. And again, look to the far right of the graph. And where does that behavior go? It goes down, so we're negative because negative people are down. Okay, so what is the minimum degree? Now this one is a little bit harder, and this is again going to take a little bit of thought process. So again, odd numbers, that's going to be our 1, 3, 5, 7, 9, ... right? Okay, there's a number of at least one x-axis, so there's going to be my 1. Okay, there's 0 turning points, which again, still anything bigger than these numbers or it can be equal to this, okay? And then for here, it's going to basically be one more than it is what you're going to start. So anything that's equal to it, you rule out. So basically I have 1, 3, 5, 7, 9. Now in our case here, remind yourself that degree 1, this is a straight line, okay? Does that look like it's straight? No, it's got a bit of a curve to it. So I'm going to rule this one out because it's actually not a perfect straight line, which means I'm going to choose 3 being my minimum degree. Okay, try this again. And again, as you go through these, remind yourself that basically we ask ourselves these same questions over and over. Look for the x-intercepts, look for those turning points, whether that leading coefficient is positive or negative. Determine whether that polynomial degree is going to be an odd or even degree, and whether the minimum possible degree by looking at the graph that you might have. Okay, so take a second and pause this and try to work this out yourself. Okay, so you've had a second to hopefully take a peek at this. And let's ask that first question there, the number of x-intercepts. So again, 1, 2, you're literally just counting, okay? This should not be that hard of homework there. So 1, 2, 3. So I got 3 as my answer. Okay, the number of turning points, and again, I go from increase to decrease to increase, 2. Okay. So what about whether that leading coefficient is positive or negative? Now, again, remember, this question here goes really well with the second question that comes after it, which is basically whether it's an even or odd degree. So again, they're kind of answered at the same time, which is why a lot of people, they struggle a little bit with it because it's better to think of these together. So this is going up, this is going down, so we know it's going to be an odd degree there. And since it is an odd degree, again, one side up, one side down, that lets me know, but again, how am I ending it? So again, look to the far right of it, and you can see that it's popped up here. So up are positive people, so it is an odd degree with a positive coefficient there. Okay, now determine the lowest possible degree. Again, it has to be odd. So again, you're going to say like right here, 3 is got your x-intercept. So it's got to be 3 or more. And then the turning points definitely kind of rules with that. It's got to be 3 or more. So therefore my minimum degree is 3. Okay. So let's try this again. And again, take a peek, and like, I want you guys to use your calculator. I'm not going to show the calculator on this one, but I'm going to show you where I see things on the graph, but I'm going to kind of make a couple of points out here of why some things are a little bit harder than others. So you've got this data from this model here, which is 2000, and it's projected to 2015, and the function is as follows: y equals a negative 0.00201 x to the fourth plus 0.05076 x to the third minus 0.37132 x squared plus 1.05544 x plus 4.23362. Now, this can be used to model the U.S. unemployment rates with X equaling the number of years after 2000. So the first thing I want you to do is I would like you to graph it, and I want you to graph it using the X values from 0 to 15, okay? Now, that first right there, again, I know a lot of people struggle when I say this, but basically this right here, this means that my X min should be 0. My X max is going to be 15. However, I am not 100% sure what my Y values are going to be, and you might have to play around with that a little bit, okay? Once you're done with that, we want to use the technology and find all of the mins and maxes, okay? To use the approximation to do that. So this is going to be, again, looking for maximums and minimums. This would be basically our second trace option. Okay, under calculate and do your max and min. And then is it likely that the model can be used after 2015? And we'll talk about whether or not it is a really good idea or not. Okay. So again, take a second, pause the video. I want you guys to try this and then I'll go over the answers, but I'm not going to show the calculator part for this one. Okay, so hopefully you've gone in and you've done the graphing, plugged it in. Now you may have struggled a little bit with the graphing where you have the X values since from 0 to 15, so you got that right, but you may not show the complete graph. So a couple of things to note that, again, this is where kind of knowing some things ahead of time is really helpful. I noticed the highest power on my X there is 4. And we know that when we see something like that, where the X is to the 4th power, we know that the shape of the graph is going to be kind of like possibly like this or like this. Okay. Now, the other thing I notice is the fact that it's got a negative in there. So because it's got the negative there, I'm going to actually flip those around to the other direction. Okay. So remind yourself that we talked about this. This has been like when we were doing transformations, is that the negative there is going to basically transform it to where it's going to be reflected across the x-axis. Okay. Now, again, there was 2 different shapes I showed, so it could have been this and could have been something like this. So keep those ideas in mind as you're looking at them. Okay. So this was the graph I got. And again, my X values were from 0 to 15, but it took me a little bit to get my Y values. And I found basically 0 to 11 worked pretty well. Okay. Now I did happen to see that there was kind of some issues kind of going in here and looking at it. And with that, I had to kind of really go in and really play with it a little bit. And so that's where I actually kind of shifted my X values or some of my Y values up to start at 4 and then go to 11. So I got a real good idea of like seeing that kind of strangeness that happened here. Okay. So again, there is a max, 2 of them, and there's actually a minimum. And again, this is a little hard to see because again, it does this kind of like small uphill and then small downhill here to get to this minimum. But you can see here that we've got 5.27 and then somehow I end up going down, decreasing a little bit to get to 5.25. And then we go back uphill to get to that. Again, these are really hard to see in the calculator sometimes. So just be a little cautious of this. And this is again where the calculator is not lying to you, but you have to be able to use it appropriately to see it there. Okay. Now, with that being said, in question B there, I was asking you to find those. So I've kind of already given them to you. And these are those exact ones there. So hopefully you're able to see them. And again, this is why I said, if you don't see it with those dots on there, it's a little hard to see that it here is that high point somewhere around here is the high point. And then we see that it kind of goes down a little bit. I had to kind of trace it a little bit to see that. This is an obvious high point here, and we can see there's kind of obvious one here, but it's that whole like, it's a little unsure whether it's actually here, if there's 2 in there, okay? Now, the last question I ask you is basically, what do you feel like the graph's going to do after the year 2015? Looking at the graph itself says that this model will keep going. However, if you'll notice that basically right after our last X value, it kind of just takes this massive dump and just kind of keeps going down, 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 down. And then basically after like X equals 15, we didn't see much, but if it continued in that downward trajectory at the end there, it's going to start going negative. And we know that eventually that makes this basically invalid, or not invalid, but makes this, it's no longer a valid model as you're looking at it, okay? So keep that in mind, is that models are only going to be good for a short period of time, and they can actually kind of just go out of existence very quickly. And I say this because, again, let me bring this back up so you guys can see the picture here. As you can see, like some point right after 16, it goes into the negatives. And remember that these outputs, these Y values that we're looking at, they're percentages, and there's no such thing as getting a negative percentage for unemployment. Now, there is such thing as a negative percentage, but there's not for unemployment. So that's where we can see very quickly here that like this model starts decreasing and then kind of looks like it's going to be kind of this like a, I'd say like a non-existent model. It's just not valid after the year 2016. It just kind of looks like right after that, like it just becomes invalid. Okay. That is 6.1. Hopefully you learned a lot of new terms. Make sure you're taking really good notes on these new terms. They are going to come back and give us a little bit more in the next couple of sections.